All right, welcome to this explainer. We've got a really exciting topic on the table today. We're unpacking a massive leap forward in automated code-based optimization, and it's all thanks to a Claude Code plugin called Evo. Honestly, if you spend your days chasing performance gains, tweaking parameters, or just trying to squeeze that last drop of efficiency out of your code, well, what we're about to cover is absolutely going to change your entire workflow. So let's kick things off with a bit of a provocative thought, right? Imagine turning your codebase into a fully autonomous research loop. We're talking about an agent that literally writes its own benchmarks, tries out a whole multitude of solutions, and iterates on your code without you lifting a single finger. You just go to sleep and wake up to a measurably better, faster, or more efficient application. Sounds like magic, right? And this really hits the nail on the head regarding the problem we all face every single day. The manual performance optimization cycle is, well, it's notoriously tedious. You gotta write the evaluation harness yourself, try a change, check the result, and if it fails, revert it. Not only is this a massive time sink, but it usually traps you in a shallow exploration path. You just naturally tend to follow whatever direction you tried last. But an automated AI loop, it can continuously experiment at a scale and speed that we humans simply can't match. Okay, let's take a lightning-fast look at our roadmap. We're covering 1. The manual optimization problem, 2. The auto-research breakthrough, 3. Evo's parallel tree search, 4. Architecture and academic roots, 5. Discover and optimize skills, and finally, running your first experiment. Let's jump right in.
Section 1. The manual optimization problem. Look, we've all been there, stuck in the performance optimization trenches. It's a super linear, rigid loop. You pick a metric, burn hours writing the benchmark, try a change, wait around for the results, and iterate. But the real issue isn't just the lost time, it's the cognitive tunneling. Because testing takes up so much of your valuable time, your exploration stays really shallow. You're not testing 10 wildly different architectural approaches, you're just tweaking the one you already committed to.
Moving on to Section 2, the auto-research breakthrough. So the first real evolution out of that manual trap came from a project by Andrej Karpathy. He introduced this concept of auto-research, which is basically a pure greedy hill climb. Karpathy gave an AI agent a small language model training setup and just let it run wild overnight. It would tweak a file, run a strict 5-minute training budget, check the validation metric, and keep the changes if they improve the score. And honestly, it's highly effective overnight. But because it's a greedy hill climb working on a single branch, if that agent wanders down a dead-end path, it gets totally stuck there until a human comes along to rescue it. And that brings us to the crucial point. Evo takes this foundational idea and completely supercharges it. It transforms this single fragile timeline into a branching multiverse. Instead of a linear chain of commits where one bad turn halts all your progress, Evo uses a parallel tree search. It explores multiple directions simultaneously. This means the optimization process never collapses just because one single path hit a dead end.
Section 3. Evo's parallel tree search. Let's look at how Evo actually builds this parallel tree search in practice. It doesn't just spin up one agent. It spawns multiple semi-autonomous subagents. Each one runs in its own totally isolated Git work tree, branching off the parent node. But here is the absolute genius part. They share a state. Failure traces, annotations, discarded hypotheses, all of this from every subagent is visible to the future subagents. So no agent ever repeats the exact same mistake its buddy just made. Plus, you can wire up custom gates like safety checks or regression tests to ensure that only code that actually works gets merged back.
All right, Section 4. Let's talk architecture and academic roots. To really grasp how these agents are so incredibly smart at exploring codebases, we kind of have to peel back the academic layers. First, for deciding which path to explore next, which is known as frontier selection, Evo pulls inspiration from the JIPA paper, standing for Genetic Pareto. It uses natural language reflection to learn high-level rules from trial and error, and it actually outperforms traditional reinforcement learning. Second, to analyze failures, it borrows from recursive language models, or RLM. It fans-out scans subagents to read massive batches of failure traces all in parallel. This lets it spot compound failure patterns and semantic root causes that a standard linear read would completely miss. And here's what that workflow looks like in action. The orchestrator scans the traces, writes up a structured brief with the objective and boundaries, and hands it straight to the subagents. Those subagents then run their hypotheses in their parallel Git work trees. Finally, the orchestrator collects the results, commits the code that survived the gating checks and actually improved the score, and just tosses the rest. The whole time, your main branch stays completely clean.
Section 5, Discover and Optimize Skills. To bring this back down to practical reality, inside a host environment like Claude Code, Evo basically operates using two primary skills. The first one is the Discover skill, and honestly, this might be the biggest quality of life improvement. The automated discovery of the benchmark is a massive leap forward. You don't even have to write the evaluation harness yourself. Evo walks through your repository, figures out exactly what is worth measuring, and sets it all up. You just review it to make sure it picked the right metric, because obviously if it picks the wrong metric, it's going to optimize your code for the wrong thing.
Once that benchmark is dialed in, you trigger the Optimize skill. By default, this unleashes 5 parallel subagents per round to just attack the benchmark. But you have total control over this multiverse through the configuration parameters. You can dictate the number of subagents, set the budget of iterations each agent gets in its branch, and this is my absolute favorite part, establish a stall limit. The stall limit is brilliant. It tells the system to automatically stop if a certain number of rounds go by with 0 improvement. That way, you aren't just endlessly burning compute cycles on a problem that has already hit its maximum optimization.
Okay, our final section, Section 6, Running Your First Experiment.
So, how do we actually get this set up on your machine so you can start reclaiming your time? Well, the prerequisites are incredibly lightweight. You really just need Git, Python 3.10 or higher, and actually, I highly recommend using UV. It's this lightning-fast Python package manager from Astral. UV basically replaces pip and virtualenv, and it operates like 10 to 100 times faster. That speed is absolutely perfect for an agentic loop that needs to spin up environments rapidly. And the best part, if you're using Claude Code, the Evo plugin comes pre-bundled. You literally just add the plugin from the marketplace right through your CLI. I absolutely love this quote from the official documentation because it just perfectly summarizes the magic of plugging this straight into your workflow. No manual experiment setup required. You hand it the code, it finds the metric, and it just goes to work. It represents this massive fundamental shift. We're moving from us writing the code to us orchestrating the agents that write the code. It's a real game changer. We have covered a lot of ground in this explainer, from these super tedious manual loops of the past, right up to the branching, parallel multiverse of Evo. But I want to leave you with this final thought as you get ready to unleash your own parallel agents. If the machine is now doing all the heavy lifting of benchmarking and optimization, what incredible things are you going to build with all that time you just got back? Thanks so much for hanging out with me. And hey, happy optimizing!